This is Geometry Notes 2.2 Day 1 and 2. The objective, to recognize conditional statements and their parts. So we're going to talk about conditionals. They're if-then statements as we go through here. Let me get rid of my pen so we can actually click on something. A conditional is an if-then statement. In symbols, it's P with this implication scenario Q, so P implies Q. Read as P then Q or P implies Q. It is made up of two parts. The hypothesis is the part P following the if statement. And the conclusion is the part Q following the then. Now keep in mind, hypothesis and conclusion are standalone statements apart from if and then. The if and then are there to signal that the hypothesis follows the if and the conclusion follows the then. Now identify the hypothesis and conclusion of each conditional. Since I have the word if, the weather is nice, then we will go swimming. P, which is the hypothesis moniker here, the weather is nice, and Q, which is the conclusion, is we will go swimming. Notice that if and then are not included in this, and they will be counted wrong if you do include them. So as I look at number 2, I underline the if and then, so I notice what's not a part of my answer. And then I'm going to put in P, which is, the hypothesis part, which is followed in the if. I ride my bike to softball practice. And then I notice the then, which is the conclusion signal, I will get there on time, as Q, I will get there on time. Now, as we continue through, we have certain rules for writing the statements as conditional statements. The hypothesis follows if or when. So if I have the words if or when in the statement, the hypothesis will follow. So it is time for dinner if it is 6 p.m. Or I could even say it is time for dinner when it is 6 p.m. Either one of those statements would mean when I was going to rewrite this, the hypothesis is in the end here. This is following the if or when statement. So if it is 6 p.m., then it is time for dinner, will be how I rewrite this statement in if-then form. Now, when I'm looking at vocabulary words are in the hypothesis, vertical angles or share a vertex, I'd be thinking subject of the sentence, and I'm thinking about the vocabulary word itself. So vertical angles share a vertex. Well, what's doing the sharing is what's in that hypothesis. So if an angle is a vertical angle, or if two angles are vertical, then they share a vertex. And so consequently, I've kind of made it so if two angles are vertical, then they share a vertex. Now, again, going with that subject vocabulary word, subjects or what is being talked about is in the hypothesis. Thanksgiving is celebrated on a Thursday. So what's being celebrated on Thursday? It's Thanksgiving. So if it is Thanksgiving, then it's celebrated on Thursday. Now, if the word only is used in the hypothesis, then the hypothesis precedes it. Now keep in mind, if the word only is used, then the hypothesis precedes it. Well, let's look at Bert goes shopping for groceries only on Wednesday. So since the word only is right here, the hypothesis is before it. So if Bert goes shopping for groceries, then it is Wednesday. Is what our if-then statement becomes when I have the term only in it. So pay attention to those little hints. They will help you rewrite in if-then form as we go. Now, how can you write dolphins are mammals as a conditional? Okay, we're going to look at this and we're thinking, well, it's dolphins that are the mammals. So if it is a dolphin, then it is a mammal. And as we go on, we're going to look at something with more of a set notation, Venn diagram look. As a picture, a conditional can look like a Venn diagram. The idea of this was supposed to be a Venn diagram, so let's pretend that this is P, this is Q, okay, and this set is inside this set, where P, the smaller set, is the things that satisfy the hypothesis, which lies inside Q, the set of things that satisfy the conclusion. So the conclusion is the bigger, more general set, and the hypothesis is more specific. So to represent dolphins or mammals as a Venn diagram, I will be looking at dolphins inside of the set of mammals. So the set of dolphin is inside mammals, the little set is the hypothesis, and the big set is the conclusion, so it'll look like this. So again, if it is a dolphin, then it is a mammal, is what our if-then statement would be, and this is what it looks like if I picture it as a Venn diagram. Now, number 4, draw a Venn diagram to illustrate the statement. Peace Corps volunteers want to help other people. So you got to be thinking, which one's the bigger set? Is it the people helpers or just the Peace Corps volunteers are the bigger set? So if you really think about it, the more specific is Peace Corps volunteers and the more general is people who want to help others. So if we got a people helpers and Peace Corps, we got to be thinking that the outside set are people helpers, the inside set are Peace Corps. So if they are a member of the Peace Corps, then they are people helpers would be our statement. Now as we go on with truth values of conditional, now in the next section we're going to determine the truth value of the conditional, whether they're true or false. A conditional is true every time the hypothesis is true and the conclusion is also true. So they have to both be true for you to determine if it's true or not. But now the not part, a conditional is false every time the hypothesis is true and the conclusion is false. So when you find one counterexample for which the hypothesis is true and the conclusion is false, you can prove a conditional is false. So, but notice that the conditional, the hypothesis part had to be true in both cases in order for us to consider the truth or falseness of the conditional itself. So the hypothesis has to be true in order for you to decide if it's true or false, and that's just based on the conclusion itself. So we have a few to determine things here. As is the conditional true or false? If it is false, find a counterexample. If a month has 28 days, then it is February. Well, that's false because all months have 28 days. January is 28, it's just February only has 28. And on leap years, it's got 29. And B, if two angles form a linear pair, then they are supplementary. A linear pair are two angles that are 180 degrees, and supplementary are just two angles. It's just a linear pair of adjacent angles, so that's true. Linear pairs are adjacent supplementary angles that sum to 180. Now, as we go on here, we're going to learn about writing converses, inverses, and contrapositive of the conditionals. That's our objective in this next section. We're going to learn about negation, converse, inverse, and contrapositive. Given the original statement P implies Q, where we find P and Q as this, defined P and Q as the sidewalk is wet, it is raining out. So we can write the original condition as if the sidewalk is wet, then it is raining outside, according to our rules laid down in the first section of this notes. We now look at something called a negation. Now this isn't on a if-then statement itself, it's just on the parts. So I'm going to go negating P, negating Q. So negating P is the sidewalk is not wet because P was the sidewalk is wet. In this next section, we're going to negate Q. So negating Q, Q was originally it is raining outside, so we're going to insert a not. It is not raining outside. Now it is important to keep in mind that as we do these negations, we don't change the wording. We either insert a not or we take out a not. We just don't say, like, for a negation of the sidewalk is wet, we don't say the sidewalk is dry because that's a different phrasing, it's a different meaning. We do just want to put in the not or take out the not. And that's as easy and as simple as we can for negations. Now we're going to use this idea of negations when we talk about inverses, but for right now we're going to get into the other areas of writing. We're going to talk about converses. A converse is a switch of the hypotenuse and the conclusion of the hypothesis is P, conclusion is Q. So if I talk about it in symbols, if I take the original statement, P implies Q, the converse of this would be Q implies P. So if I was going to take this statement, and by the way, we're going to take this statement each time just to be familiar with something. This is in our original P implies Q order. I'm going to take this and switch this to be a converse. So if the sidewalk is wet, then it is raining outside, will become if it is raining outside, then the sidewalk is wet. Please notice how I switched the order, that the hypothesis went to the conclusion and the conclusion went back to the hypothesis according to our shortcut in symbols. Now, to do the negation of converse inverse, now this I repeated, so I'm just going to bring this in. This is the original statement that we're working with. So you can see it on your page. I can't see it on mine because I'm on a different screen. But we're going to talk about inverses now, and this is why we learned about negations. Now, instead of negating just one thing, we're going to negate both. So negate both the hypothesis a P in the conclusion Q, but they stay in the same order as the original statement. So P implies Q was the original statement. The inverse is in symbols, not P implies not Q. So I've negated the first and negated the second. So I'm just taking the opposite of the meaning of the hypothesis and that of the conclusion. So here in our original example, if the sidewalk is wet, then it is not raining, or it is raining outside, excuse me, will become, if the sidewalk is not wet, then it is not raining outside. And please notice the difference from the original to the change with my red, or different colored not inserted in the hypothesis and conclusion and keeping it in the same order. Now we have something called a contrapositive. The contrapositive is the inverse converse. You know, it's a negation and a switch of both the hypothesis and conclusion. So the contrapositive combines inverse and converse. So we're going to negate the hypothesis P and the conclusion Q of the original statement, P implies Q, and switch their positions. So the contrapositive in symbols is not Q implies not P. So this idea of this statement, I will have the nots in there, but it's going to switch these two. So it'll become, as we look at it, if it is not raining outside, then the sidewalk is not wet. And please notice that we negated the hypothesis and put it in the conclusion, negated the conclusion and put it in the hypothesis. So those are the three ways we're going to learn about writing if-then statements in the different forms. First, we're going to learn we've learned how to write them in if-then form. Then we do inverse, converse, and contrapositives. Now, writing the converse, inverse, and contrapositive of the following statement. Remember, rewrite the original statement as a conditional, P implies Q, if it is not already in if-then form. Now, odd natural numbers less than 8 are prime. So the if-then form, I'm talking about odd natural numbers. If a number is an odd natural number less than 8, then it is prime. Now, keep in mind, a prime number is a number that's factors only one in itself. Okay, so the converse. So I switched the hypothesis and conclusion. I've got this Q implies P. So, and because I'm talking about a number, that term it, for readability, I'm going to leave a number there, and odd natural numbers is going to switch with primes here for my converse. So when I would do this, if a number is prime, then it is an odd natural number less than 8. Okay, so I did my switch, but for readability, I want to know what I'm talking about before I get to the last end of my statement. I just left a number in there, and it is referring to a number. But now the inverse, remember the inverse is negation of the original statement's hypothesis and conclusion, and that's the only thing. So here I'm just going to rewrite, and if a number is not an odd natural number less than 8, then it is not a prime number, not prime, or not a prime number. So we have that negation put in there for the inverse, and now I'm going to do the contrapositive, which is negate switch, and if a number is not prime, then it is not an odd natural number less than 8. So I pretty much took the converse and put the not in here and here to make it work. But now, after I do that rewrite, I'm going to answer some questions. Using the original conditional, converse, inverse, and contrapositives you wrote above, determine the truth value of the statement. Well, these are my truth values here that we're talking about, whether they're true or false. Okay, but let's talk about it. If a number is an odd natural number less than 8, which is 1, 3, 5, 7, then it is prime, and all those are prime numbers. If a number is a prime, then it is an odd natural number less than 8. Well, not all primes are less than 8, so that's false. If a number is not an odd natural number less than 8, then it is not prime. Well, there are more primes than just the odd numbers less than 8, so that's false as well. And if a number is not prime, then it is not an odd number less than 8. That's true too, because the only even number that's prime is 2. So the rest of them are all odd. So we're all good. So here we have the truth values of original, converse, inverse, and contrapositive. Which of the statements you wrote above have the same truth value? Well, the original and the contrapositive, the converse and the inverse. So that's what I wrote. And now we're going to find out there's a connection between the original and contrapositive and the converse and the inverse. And you should star these. You should know this. This helps you make determinations on things. an original conditional and its contrapositive are equivalent statements. They are either both true or both false. So they always have the same truth value. And the inverse and the converse of a statement are also equivalent statements. They are either both true or both false. Okay, but to determine them, you have to write them separately. So with that said, there's a unique situation I want to bring up, and I only do this because of kind of being holistic about this subject. A unique situation, what is the truth value of a conditional when the hypothesis is false? Please notice that we always determine the truth or falseness of a if-then statement based on the hypothesis being true. But here we're bringing up a situation where it's false. And what happens if it is false and the conclusion is true? Well, we define it as a true conditional. And if the hypothesis is false and the conclusion is false, we still define it as a true biconditional. So if all elements have pink polka dots, then bicycles have wheels. Well, that's true because pink polka dots is false if it's a real elephant, so there you are. If monkeys have wings, then water is dry. Well, that's true as well, because monkeys don't have wings, except for Wizard of Oz, and water is not dry, it's rather wet. So, again, this is a very unique situation, but I just wanted to include it to be kind of complete on this little tip of the iceberg that is tautologies and truth values. And that's it for notes for this section. So I hope this was helpful. If you have any questions, please bring them up to Mr. Bloom in class or the before and after school helps. Have yourself an excellent day.